Let's discuss the images and digital images in more details. Suppose we take an image from an animal. For the moment, let's make things easy and suppose that the photo is black and white or grayscale, so there is no color. We may consider this image as being a two-dimensional function where the function values give the brightness of the image at any given point. As you can see in this image, for example, in this point, the brightness of this pixel or the grayscale value of this pixel is 0.8. We may assume that in such an image, brightness value can be any real numbers in the range 0 to 1, so 0 for black and 1 for the white. And the ranges of x and y will clearly depend on the image size, but they can take all real values between their minima and maxima. A digital image differs from a photo because in the digital image, the x, y, and f of x and y values are all discrete, and usually they take on only integer values. The previous image will have x and y ranging from 1 to 512 each, and the brightness values are ranging from 0 to 255. A digital image can be considered as a large array of discrete dots, each of which has a brightness associated with it. These dots are called picture elements or pixels. The pixels surrounding a given pixel constitute its neighborhood. A neighborhood can be characterized by its shape in the same way as a matrix. So we can have a 3 by 3 neighborhood or 5 by 7 neighborhood. In most of the cases, the neighborhoods have odd numbers of rows and columns in order to guarantee that the current pixel is in the center of the neighborhood. In this image, you can see an example of neighborhood with size 3 by 5. There are 4 types of images. Binary image. In this type of image, each pixel is just black or white. Since there are only 2 possible values for each pixel, we only need 1 bit per pixel. So such images can therefore be very efficient in terms of storage. This type of images are suitable for text, fingerprints, and architectural plans. For example, here you can see a binary image. There are only 2 colors, white for the edges and black for the background. Grayscale is another type of the images. Each pixel is a shade of gray, normally from 0 for black to 255 for white. This range means that each pixel can be represented by 8 bits or exactly 1 byte. This is a very natural range for image file handling. Other grayscale range are used, but generally they are a power of 2. Such image arise in medicine or X-ray. Of course, 256 different gray levels is sufficient for the recognition of most natural objects. In this image, you can see an example of grayscale image. This is a street scene, and the intensity values of the pixels for some part of the image are displayed in the right side. The next image type is TrueColor or RGB. In this type of image, each pixel has a particular color, that color being described by the amount of red, green, and blue in it. If each of these components has a range 0 to 255, this gives a total of 255 power 3 or approximately 16 million different possible colors in the image, and this is enough color for any image. So since the total number of bits required for each pixel is 24, such images are called 24-bit color images. RGB image may be also considered as consisting of a stack of 3 matrices representing the red, green, and blue values for each pixel. This means that for every pixel there correspond 3 values, as you can see in this image. And the last image type is indexed. Most color images only have a small subset of the 16 million possible colors. For convenience of storage and file handling, the image has an associated color map or color palette, which is simply a list of all of the colors used in the image. Each pixel has a value which does not give its color, but an index of the color in the map. For example, if an image has 256 colors or less, then for the index value we only need 1 byte to store. Some image file formats like GIF allow only 256 colors or fewer in each image because they follow this idea of index color. As you can see in this image, the indices, rather than being the gray values of the pixels, are simply indices into the color map. Without the color map, the image would be very dark and colorless. But in this figure, for example, pixel label 5 corresponding to 0.26, 0.25, 0.25, which is a dark grayish color.